Hello students, let us discuss the next set of reaction, oxidation. So alcohols undergo oxidation under different circumstances with different oxidizing agents, and the products accordingly are different. So if we take primary alcohol, it will undergo oxidation to form aldehyde first. Okay, and if your oxidizing agent is strong enough, then it will further undergo oxidation to give you carboxylic acid having same number of carbon as you have taken in alcohol. However, if it is a secondary alcohol, then on oxidation it will form a ketone. Ketones are more difficult to oxidize. However, if you maintain a drastic condition, then ketones do get oxidized, but in that case they form mixture of carboxylic acids, and each of the acids formed will have lesser number of carbon than the alcohol taken. So we can consider it to be a step down reaction. So we'll take examples under this. Now you need to know which oxidizing agents are strong and which ones are weak. Under strong oxidizing agents, the most common examples are KMnO4 with sulfuric acid and potassium dichromate with sulfuric acid. Under the mild oxidizing agents, we have chromic oxide. We have another oxidizing agent, we call it PCC, which is a mild and selective oxidizing agent. We shall talk about it later. So let us try to understand the reaction with strong oxidizing agent. We have taken an alcohol with 2 carbons, ethanol, and you can see it is a primary alcohol. So when you oxidize by using any oxidizing agent, it is supposed to form aldehyde. So here we had 2 carbon, so the aldehyde also will have 2 carbon. So ethanol will form ethanol. On further oxidation, it forms ethanoic acid. However, if you take a secondary alcohol, the simplest secondary alcohol known is propan-2-ol, which has 3 carbon. So on oxidation, propanol will form propanone, which is a ketone having 3 carbon. Now you see the ketone, if you further oxidize, then what will happen? The ketone will, on oxidation, the CO bond across carbonyl group, one of the CO bonds across carbonyl group will break. So on one side we have 2 carbon, so it will get oxidized to form ethanoic acid. On the other side we have 1 carbon, so the acid with 1 carbon is formic acid. So these 2 acids will be formed. So remember how to write the products. This side it is easy to guess, but this side is little difficult. Now if we take a mild oxidizing agent such as chromic oxide, then the reaction will stop at aldehyde stage. No further oxidation will occur to form carboxylic acid. Now you see PCC, the full form of PCC is pyridinium chlorochromate. Pyridinium chlorochromate is a selective mild oxidizing agent. Now why do we call it selective? You take this example. If you have this particular compound where you have a primary alcoholic group as well as a double bond, both the groups are prone to oxidation. That means both are capable of undergoing oxidation. So if you take PCC, then what will happen? The double bond will remain untouched, it will remain intact, and the primary alcohol group will get oxidized to aldehyde. Now since PCC is a mild oxidizing agent, the product will not form carboxylic acid, it will form aldehyde only. However, if you take a strong oxidizing agent such as KMnO4, then you can see this alcohol group has formed carboxylic acid and the alkene will form diol. So PCC is very useful when you want to carry out a selective oxidation. Our next category of reaction is dehydrogenation, that is removal of hydrogen. Both oxidation and dehydrogenation, the products are similar, but the thing is, in oxidation the byproduct formed is water because there is a source of oxygen, and dehydrogenation is just removal of hydrogen. As you know, one of the definitions of oxidation is removal of hydrogen. So in oxidation we are removing hydrogen, in dehydrogenation also we are removing hydrogen. Of course the reagents are different, and the byproducts in oxidation will be water and in dehydrogenation is hydrogen. And the interesting aspect of dehydrogenation reaction is it stops the reaction at aldehyde and ketone stage. There is no scope that it will further get oxidized. So what happens here, the reagents used here is either copper or silver at 573 Kelvin. Now primary alcohol give you aldehyde plus hydrogen, secondary alcohol give you ketone plus hydrogen. Interestingly, tertiary alcohol give you alkene and water, just like dehydrogenation reaction. So this is a better method if you want to prepare aldehyde and ketone. Now for your reference, let me tell you, our next chapter will be aldehyde ketone. All these methods you have to do under preparation of aldehydes and ketones. So let's take example CH3CH2OH with copper. Since we have two carbons here, alcohol having two carbons, so aldehyde formed will have two carbons since it is a primary alcohol. In second example, we have taken propanol, which is a secondary alcohol having 3 carbon, so it will form a ketone having 3 carbon. Whereas here we have taken a tertiary alcohol, and you notice the product formed is neither an aldehyde nor ketone but an alkene. So with this we come to the end of reactions of alcohol. Next we'll have the topic phenol, and here I have given you some in-text question. Please try to solve them. And as I always say, if you have any doubts, please feel free to ask, and it will be nice if you share your answers. Thank you.